In the spring of 1900, a Greek sponge diver surfaced with a bronze hand. Everyone looked at the statues. No one looked at the lump of corroded metal sitting in the corner of the same room. It took 2 years for someone to notice the gear, and it took 124 more years to count the holes correctly. When they finally did, the date changed. By the time researchers began studying what the lump actually contained, they found 30 bronze gears, interlocking, precisely calibrated, arranged in differential gear trains that tracked the sun, the moon, and all 5 planets visible to the naked eye. Inscriptions inside described their motions. X-ray scans confirmed the geometry. This was a working model of the cosmos, built into a box the size of a shoebox sometime around 87 BCE. The accepted interpretation held for decades, a solar calendar, 365 days, consistent with Hellenistic astronomical practice. Sophisticated, yes. Remarkable, certainly, but within what the ancient world was expected to know. The gap it left in history was harder to explain. Nothing comparable to this mechanism's complexity appears in any archaeological record until the astronomical clocks of 14th century Europe. That is 14 centuries of silence. 14 centuries during which every craftsman who could have built this either did not or built something that did not survive. The mechanism sat alone in time, a device without ancestors, without descendants, without parallel. In the summer of 2024, 2 physicists at the University of Glasgow published a paper in the Horological journal. Their names were Woan and Joseph Bayley. They were not archaeologists. They were not classicists. They worked with gravitational waves, the ripples in space-time that LIGO detects when black holes collide billions of light-years away. The statistical methods required to hear a gravitational wave through cosmic noise are among the most precise measurement tools ever developed. Woan and Bayley applied them to a ring of holes on a corroded bronze artifact. They wanted to know exactly how many holes the ring contained. The calendar ring on the Antikythera mechanism is damaged. Fragments are missing. What survives shows holes punched at regular intervals around a circle. Earlier researchers estimated the total count at 365, 1 hole per day of the solar year. A tidy answer, the one everyone had assumed. Woan and Bayley's Bayesian analysis said otherwise. The average distance between each surviving hole varied by exactly 0.028 millimeters. That is 28 micrometers, finer than the width of a human hair. And at that precision with the spacing pattern their analysis extracted, the ring contained not 365 holes. It contained 354. 355 at the outer, credible limit. The paper's conclusion was direct. 365 holes is not plausible. 354 days. That is a lunar year, the time it takes the moon to complete 12 full cycles. Not the sun's calendar, the moon's. The mechanism was not tracking solar time on that ring. It was tracking the moon. And whoever punched those holes into a bronze ring 2,000 years ago did so with a consistency of spacing that required either a mechanical process of extraordinary refinement or a hand steady enough to maintain 28 micrometer precision across an entire circle. Either possibility rewrites what that object is. The question that follows has no clean answer. Cicero wrote in the 1st century BCE about mechanical devices that modelled the heavens, devices built in the tradition of Archimedes 3 centuries before. There was a lineage, a craft tradition that stretched back further than the shipwreck. But the Antikythera mechanism is the only physical object from that lineage that survives. Not one contemporary parallel has been excavated from any Hellenistic site. Some scholars argue for a single extraordinary craftsman, a mind capable of conceiving and executing the whole design alone. Others argue that the precision implies something more entrenched, a workshop, a school, a tradition of tools and techniques passed between craftsmen over generations, a high-end workshop, as one historian put it, that existed around 100 BCE and apparently nowhere else. Both arguments are plausible. Neither can be confirmed. The physical record contains exactly one data point. Why only one? Bronze was currency in a more direct sense than we use the word. It was material, and material had value, and when a device stopped working, it was melted. The mechanism survived because the ship carrying it sank. The seabed preserved what commerce would have destroyed. Every other device of comparable sophistication that ever existed was either worn until it failed and then melted for the metal, or lost to conditions that left nothing recoverable. The wreck at Antikythera was not special because a great ship sank. It was special because something sank before anyone could recycle it. If one corroded fragment examined with the statistical tools built to detect gravitational waves can reveal that ancient craftsmen punched holes to 28 micrometer precision and tracked the moon rather than the sun, then the silence around this object becomes its own kind of evidence, not of absence, but of loss. Somewhere, a tradition capable of this existed. It left one object. The ocean kept it. The land kept nothing. The corroded lump is still in Athens. It weighs less than you would expect. It looks like nothing. And now you know that inside it, punched at intervals of 28 micrometers by hands that have been dust for 2,000 years, 354 holes mark a lunar calendar built by someone whose name we will never know, in a tradition that left no other trace. Was this the work of a single mind or the last surviving output of a lost workshop? The object cannot say. It only survives.